Hello, my name is Ryan Reed, and today I will be going over Lorena and I's final project, which is the mobile robot system. So to start you off, I'm going to first talk about the description of the solution, then move on to a little demonstration and show you how the robot works, and then I'll move on to the conclusion. So the ultimate goal for this project was to program and design a mobile robot that can approach certain objects and then stop once it got to a certain distance, a limiting distance if you would call it that. And that distance was basically the length of the car. I will grab the robot and go over some of the components real quick and just give you a brief overview before we go any further. So, as you can see here, it is a two-wheeled robot system. Kind of moves in the way a skid steer would. So you have two wheels, two DC motors, which will control each wheel individually. You have a Arduino board, a breadboard to make your connections, and then also a driver board, which helps make connections from the Arduino to the motors and the servos. We also have a servo, which is going to swivel the eyes, and then this ultrasonic sensor is basically the eyes. And we'll go into a little more depth later about how each of those components work. So to sum up kind of why this project was important for this class, this mechatronics class was all about coding, mixing coding with mechanical operations and wiring. And so everything that we learned in class, from coding with MATLAB, how circuits work and wiring, and mechanical properties, how servo motors work, how ultrasonic sensors work, and how they read information and output something else. This was all demonstrated in this project, and some of that I will go over when we get to the components in just a little bit. So now I'm going to set up a few items, and we will move on to a little demonstration showing how the robot works. I'll try to take you guys with me so you can see not only the robot moving, but how the code interacts with the robot as well.
So here we're on to the demonstration part of our video. In a second, we're going to start, and you see that it does its full 180-degree scan of the view, and then a prompt pops up asking the user what direction they'd like to travel in. So we'll start with just doing a little demonstration of it moving around, going forwards, backwards, left, and right. That does all work as planned. And now we're going to approach an object so you can see how it touches and recognizes that it's within its limits. And here is where it could be improved a little bit. The object or the robot does scan once it reaches its touching limit. However, it tends to get stuck in a loop because it goes past its touching limit a little bit. So when it's backing up, it's still recognizing that it's touching rather than out of its touching limit. So it scans a few times, and then finally it is out of its touching limit. And so the user can back out and approach another object at this point. And as you can see, sometimes it gets a little too close, and the touching does not recognize, and the user has to manually stop it.
All right, so now that we have shown you a demonstration of how our robot works, we're going to go ahead and move on to the final thoughts and conclusions of our project. So as you saw, the robot does function as expected. It does move forward, backwards, left, right,
and approach an object, stop, scan, and rescan. However, there are a couple of improvements we would make due to the results that we saw. So first of all, the robot only touched and stopped and rescanned about 50% of the time. The other 50%, it would either hit the robot or just not read that it's supposed to stop due to the ultrasonic sensor sending to the MATLAB code that the distance was either infinity or too large or too just wrong. So that is something that I would improve by updating the ultrasonic sensor, maybe swapping out with a new one, and as well as updating the code. The code is currently set to only update the current position once a user picks a direction. I would like to update that to be a constant reading so that the code is always reading the current position. That way the robot can stop more efficiently and consistently. However, due to the improvements that we made over the last day, which were swapping out the motors, the motor driver, the breadboard, and rewiring, we had to do that because some of our components stopped working, which was causing failure for the movement as well as the scanning. But after we made those swaps and improvements, the robot does function as you saw. So we did set out and accomplish the requirements that were set for this project.